And in addition to the two cases that we showed before, sometimes we may have some special records, and this record may have some repeating fields. What does this mean? We show you with the example, right? We may have a record contains a variable number of occurrence of a field. However, this field may have a fixed length. For example, an employee may have one or more children, right? And if we want to store this employee as a record into the database system, then how can we store this kind of children information? For different employees, the children information can be different, right? Even though for each of the children, the information available for the children is a fixed length, right? Then how can we store this kind of information into a DBMS and into a file? So actually, we can group all the occurrence of the fields, this kind of variable number of occurrence of the fields together. Because for this kind of occurrence of fields, we can just use a pointer pointing to concrete children, right, of the employee. And therefore, this kind of occurrence, each of the occurrence, they will take a fixed length of the storage space. And we can group them all together. However, to denote the starting address of this field, we need to put in the record header with a pointer pointing to the first entry or first occurrence of this kind of fields. At the bottom, we show the example of the storage format. We still have the header. The header have a pointer pointing to some other header information, and with the length of this record, the whole record, and the pointers pointing to both the first variable length attribute or the field we showed before, right? And for the ones with the variable occurrence, then we can group them together, right? Now this employee may have multiple children, 5 children. For each of children, we have one pointer in the field pointing to the children records, right? We have 5 pointers as shown here. We'll group them together, and we also add one pointer in the header, and this pointer will be pointing to the first occurrence of the field. In this way, we will be able to store this kinds of record with the variable number of occurrence of the field. However, this field may have a fixed length, right, as shown here. These pointers, this kinds of storage space among all the pointers will be the same actually. Okay, so this is about how to represent a records with repeating fields, which will be slightly different compared with the previous 2 examples. Alright, so we have already shown how to represent or how to organize the information into a record depending on different cases. Then the next question in our mind will be how to store this kind of records into the hard drive or into the disk, which will be slightly different, right? Because we need to consider the disk format as well as the disk storage space. So then the main question will be, given a disk, and in the disk we may have multiple blocks. Each block will have a fixed length, right? Normally for each block will be 4K for storing the data, right? We have multiple blocks for storing the records. We may have to put these records into these blocks, right? Then the main question, how can we put these records into the blocks? So we can make full use of the storage space. And for the ones which exceeding the size of the blocks, how can we store them? Which will be very difficult and also an open question. So here we assume that the blocks may have a fixed size. Typically it is 4K. And we also assume that the record size are much smaller than a block size. So we can put a record into a block, right? For the record size which are larger than the blocks, then we probably need to use multiple blocks to store the one single record, which will be another problem. And we assume the record size are much smaller than block size. Then the question will be, how can you put the record into a block? So the organization format actually is very similar to the previous one we showed before for storing the fields of one single record. If we have multiple records, then we can put the record into one block in a sequential manner. Now we have 4 records here, record 1, record 2, record 3, and record 4. We want to put them all into one single block, and this rectangle denotes one block. And we can put them into a sequential manner, record 1 first, and its starting address can be the starting address here, right? Then we can have record 2. Its starting address can be denoted by one pointer, which in the header part of the block, we have one pointer pointing to the starting address of record 2. And we have record 3, which we also have one pointer pointing to the starting address, similar for record 4 as shown here. And for the space which are grayed out, that denotes the space which are not used in the block. In this way, we can sort the records into a sequential manner and also store them into one single block, right, in a sequential manner. And we have a pointer pointing to the starting address for the records. And for this R1, because we know the starting address will be the beginning address of the block, we don't need to use the pointer pointing to its beginning address by default. So this is one way for storing the records into a block. However, sometimes if we keep putting the record into a block, as we are putting more record into a block, sometimes for some records we probably cannot put them into the block, because the storage space in the block probably is not enough for us to put one single or the whole record into it. Then how can we address this kind of problem? And we have two different ways to solve this problem.